All right, so for question 1, I'm going to get x by itself on one side. So I'm going to add 9 there. That'll be 51 plus 9, 60. We'll divide by 6. So x squared would be equal to 10. And now to solve this, we got to remember when we introduce a square root into a problem, we automatically should put the plus and minus in front of that. If we could break down the radical, we would, but nothing is going to go into 10 that's a perfect square. Okay, we're going to multiply two imaginary numbers here. One key to remember is by definition I squared is equal to negative 1. So just going to do FOIL, 2 times 2 is 4, 2 times 7i, this would be plus 14i. Now this is going to turn around and be minus 14i, so those two terms will cancel each other out. Negative 7i times 7i would become negative 49i squared, but remember I squared is equal to negative 1, so this is going to be 4 plus 49, and so final answer there should be 53. Alright, just going to break down a radical here. Now you can use a factor tree if you prefer. The biggest perfect square that'll divide into 98 is 49, and if you have a negative under the square root, remember we just remove that with an I, just I by itself is equal to the square root of negative 1. So that's how we define taking a square root of a negative number with imaginary values. So this would be 8 plus 7i, that's going to be the square root of that negative 49, radical 2, can't do anything else there. Okay, solve the system. I would look at these. You could use substitution or elimination here. To me, I'm looking at this and I'm thinking it would be really easy to use elimination. Either I could match up the x's or the y's. I'm going to take the top line, multiply it by negative 5. I'm just going to write it underneath here. This would be negative 5x plus 20y equals negative 25. Now, this ends up being interesting because when we add the bottom line to the top line, 5 and negative 5 cancel. Now, when we created this, these actually also cancel, and these also actually cancel. However, think about it like this. This whole side would become 0. This whole side would become 0. Now, if this is a true statement, that means these are the same line that's got infinite solutions. If I had gotten something that wasn't true, that would be no solution. Maybe something like 5 equals 3 or whatever. If you get x equals a number or y equals a number, then that system would actually have a solution. Okay, here's a data set, and we're going to find the mean, median, and mode. Okay, so really quickly, if I wanted to, I would put this into my calculator. Just to save myself a little bit of time, I'm going to go to Stat Edit, and I'm just going to clear out what I have in this list, and I'm going to type these data values. We got 27 3 times, that's going to be our mode. Oops, we got 33 times, so we've got 2 modes here. Okay, once I've got that in, we'll go to Stat Calc, and the very first button, the first variable statistics, that'll give us our mean and our median. Just keep hitting enter till it shows up. So the mean here, let's go 28.6-ish to the nearest tenth. Sorry, we didn't tell you what to round. Your median, remember, you can also see on here, or you can do this by hand. Median should be 28. And now mode is not displayed in the screen here, so we have 27 3 times and we have 33 times. So you actually have 2 modes for this data set, 27 and 30. And let's slide up to do number 6. Okay, so vertex form, a times x minus h squared plus k. I'm just going to use the space above here. A is the same in both forms. So for this question, I already know this is going to be 1/3. Now, x and y should be variables. What we need to find are the h and k. H is the x-coordinate of the vertex. You can find that doing negative b over 2a. K is the y-coordinate of the vertex, and we find that by plugging in negative b over 2a. So for this question, negative 18, now I would put parentheses around this if I was doing this in my calculator, 2 times my a value, which is 1/3. This ends up being negative 27. So this is going to be my h. Now, in the format here, this is minus h, so since this ended up being a negative value, I'm going to write plus 27. Okay, and then the only other thing we need to find is k. So this is the x-coordinate of the vertex. If I want the y-coordinate, we just plug it in. So I'm going to do 1/3 times negative 27 squared. Now make sure you put that negative on the inside of the parentheses and the squared on the outside. 18 times negative 27, and then minus 4, and this ends up being a huge number. It's negative 247. So that's my k value. So I'm going to write minus 247, and that is the exact same quadratic written in vertex form. Okay, rational root theorem is plus or minus all the factors of p and q. P is going to be any factors of your constant term. For this problem, the constant term is 8, so all those factors 1, 2, 4, and 8. Q is going to be the coefficient of your leading term or your leading coefficient. So the highest power of x here, x to the 4th, that coefficient is 2. Any factors of that are 1 and 2. Okay, so when I set this up, plus and minus, every single one of these numbers over 1. So 1 over 1, 2 over 1, 4 over 1, 8 over 1. Now, I probably wouldn't write it as those values when I did the problem. I would probably just write 1, 2, 4, and 8. Okay, and then we also have to put all those numbers over the other factor of q here. So plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 4 over 2, and then plus or minus 8 over 2. Now, if we simplified these, 8 over 2 is 4. So we've already got that covered. 4 over 2 is 2. We've already got that covered. And 2 over 2 is equal to 1. So we've already got that covered. So in terms of my answer here, I'd write plus or minus all these values. I just don't have a lot of space. We have 1/2, 1, 2, 4, and 8. Those are all the possible rational roots for this polynomial function. Here's number 8. Want to find intervals for which the graph is positive and negative. Okay, positive values are when your y-coordinates are above the x-axis, and negative is going to be when you are dipped below the x-axis. So we're just going to write these intervals real quick. You always want to move from left to right. These are always based on x values. This particular interval right here for x values, as I'm approaching this way, this term, or this little piece right here, negative infinity, and then it switches over right at the x-axis, so negative 1.5. These are both soft brackets because at 0 I'm not technically positive or negative, so that's that first interval. This interval dips below the x-axis, and that's from negative 1.5 over here to 2. Again, soft brackets at 0 were not considered positive or negative. Then I'm going to come above the x-axis, so this interval here would be from 2 to 7. Now my graph is positive, and I think this is the trickiest one to write. The rest of your graph, I know this is pointing down, but if you think about as you're moving to the right, your x values are going towards infinity. So the interval here is from 7 to positive infinity, even though that graph is going down. The interval is talking about the x-coordinates, so starting at 7, for the rest of this graph, for like 8, 9, 10, 11, 12, as I go to infinity, the rest of the graph is negative. So these two intervals here are the positive intervals, these two are the negative. Okay, for number 9, we just solve this like a normal equation. We got 36x squared equals, negative 25 divided by 36. Now, you're probably thinking that's not a nice number, but what I want you to notice, these are both perfect squares. When I take the square root, I introduce the square root, so don't forget the plus or minus. Square root of 25 is 5, square root of 36 is 6, and because we had a negative here, we just want to make sure we write an I next to our answer. For number 10, I want to go ahead and find the actual roots of the polynomial function. So you might want to change your window. We've been doing a lot of stuff with statistics right before we're taking the final here, so you might have kind of a weird weird window going on. So I just hit the button for window right here, and I just did like -10 to 10 for my x's and -10 to 10 for my y's. We can always change that. Now I've got some stuff stored in here. I'm going to go ahead and turn my plot off. Just arrow up, hit enter to do that so it's not highlighted. Sometimes some of these graphing calculators won't graph a different function if you've got values in your stat and they're trying to plot points. So just doing this, typing it in, and I'm going to go ahead and hit graph. Okay, so we're looking for nice numbers where this goes through. Now to me, this looks like -3, 2, and 6. So I'm going to jot that down just really quick. -3, 2, and 6. Those look like the actual places the graph crosses the x-axis. I'm just going to do second table real quick to verify that. Right here at 6, you can see the y value is 0, so that's good. Let me move down here. At 2, y value is 0, so that was also correct. And then just verify real quick. Yep, -3, 0. So those are the actual zeros of that polynomial function, the actual places the graph crosses the x-axis. Okay, and one more on this page. General format of absolute value function. Oh, I don't know, I just put a squared on there, sorry. Absolute value of x minus h plus k. hk is the vertex. Now a would be if we have any kind of a slope. So look at your vertex here. This is the point 3, 4. We're going to use that in a second. I'm just going down 1 over 1, down 1 over 1 on either side here. So a is just going to be -1. If my slope was something different, then we would have something, maybe a different a value there. So the a is the slope of either side of the v. If it's pointing down, it's going to be negative. If the v goes up, that a value will always be positive. Now, all we have to do is put this in, -1. You could just write a negative symbol. And then x, now this is 3, so it's going to be -3. And then plus k, which would be 4. There's your equation for the absolute value function, and that's page 1.